For today's exercise, we'll look at overriding methods that are defined in the base class. And I want to go back to the shape class to actually illustrate this. So remember that we had a car which extends shape, so it's a subclass of shape, and it has a draw car method. We also have face, and face also extends shape, and it has a draw face method. And we had the shape class, which allowed us to set the location and get the location. So that is what the base class was saying, that every single class had a top left x and y coordinate, a width and a height. So that is joined in the superclass and what we can deal with in the base class here. Where this was used is in the faces method, where when we were painting, we basically created the right at first with the shape was a face, then another example with a car, and the only thing that we had to change was the call to either draw face or draw car, depending on the shape that we were working with, because set location, width and height was shared by the base class. So I want to take this a little bit further. I want to create a method that they all have in common as well, namely the notion that we can draw them. So let me first define this in the base class, that I have a default implementation of draw, which takes a graphics object, which is the canvas, and I'm going to have a default implementation that I just draw the rectangle, or basically the bounding box for the shape. So I'm going to do the canvas dot draw rect. Yeah, draw rectangle. And the x coordinates, y coordinates, width and height are the arguments. So this is basically drawing the bounding box. And then if I want to go to the subclasses, I basically want to replace that draw with, in this case, drawing of a face. So I'm going to override the method rather than create a brand new method. And I will do the same thing for the car. I'm going to override the draw car method with, instead of having a separate method, I'm just going to override the default draw implementation. In this case then, what I want to do is simply draw, and it doesn't really matter if I have a shape, if the shape is a face or a car. The drawing is the same, and I can even just, actually let's leave it like this, so if it's a car, and I can just say it's a shape that sets the location, sets the width, set the height and the draw, and it wouldn't matter if it was a shape, the shape was a face or a car. Alright, let's compile this. And run it. And you notice that it's now drawing all the cars very nicely. I can also, instead of using the car, I can use a face instead. And now the only thing I had to change was the type, and I get to draw the faces. But I can even take it another step further. I can even say that this here is just a generic shape. And it should draw now the rectangles. And as you can see, it draws a bunch of rectangles in the space. There is another thing that I can do. If I wanted to draw the faces, I could just specify that this here is a shape. And what will it now actually draw? Will it draw the rectangle when we're calling the draw method here, or is it actually going to draw the face? So let's take a look at this. And it draws the faces because it doesn't care about the type of the object. The only thing that it cares about is the only thing it actually cares about is the actual type of the instance that the draw is called on, not the type of the variable. Let me actually close that. I want to take this one step further. Right now what I'm doing is I'm creating this number of faces. I'm creating these variables every single time. What I'm actually going to do is I'm going to initialize an array at the constructor. So I'm going to create an array of shapes. And I'm going to call it a shape array, and let's make it of size 10. And these all, this here one should be private. So I'm going to create an instance variable that is an array of shapes. I'm creating it in the constructor. And as I'm going through my loop, and I'm going to create 10 of them, I am going to sometimes I'm going to cycle between these different types. So I'm going to say if index modulo 3 is equal to 0, let's draw a face. So I'm going to say that shapes at index is a face, else if index modulo 3 is equal to 1, shapes at index is equal to a new car, else. So remember, there's only 3 possible values when you take modulo 3. Then shapes at index is just going to be a new shape. And I can set the width, the height, and the location. I can do that here, or I can do that in, I will do that over there. So the only thing that I want to do is actually draw the instances, and then as I am doing the actual drawing, I will set this. So in this case, I don't want to use the shape. Don't want to create a new one. I want to grab the shape that is in my actual array. And I don't know what type it is, alright? And I don't need to know. All I know is that I can set the location, set the width, set the height, and then I can draw it and continue on from there. Alright, so let's compile this. This here shape is not defined, so what is the type of this shape is right there. And the name of this variable is shapes. And if I now run the faces, I should see 3 different shapes appear as I'm going through here. And there they are. So notice that every third has a different shape because that's how I created it in the array. Okay, so this is a way of showing that the overridden method will be called depending on what the actual instance of the shape is. It does not matter what the type is. And it allows us to work with a hierarchy, and this is known as polymorphism.